these next examples involve naming ionic compounds that contain polyatomic ions. The most important thing about naming these compounds is you have to have the polyatomic ions memorized. I can't stress how important this is, not only for naming compounds, but throughout the 2 semesters of general chemistry and for your courses beyond that. So in these first 2 examples, we're given the names and we want to write the formulas. So just like in the binary ionic compounds, we want to write down the formulas of the ions along with their charges. So sodium is in the first column of the periodic table, so it has a +1 charge. So I've got Na+. Sulfate is one of the polyatomic ions, and it has the formula SO4. It has a 2 negative charge. Alright, so when I write the formulas for these, in order for these to balance out, because the sulfate is -2, I need 2 sodiums to balance that out. Or if I use the trick where I swap the charges for the subscripts, the sulfate will get a 1 subscript, and the sodium will get a 2. So the formula is Na2SO4. Alright, in the next example, we want to write the formula for copper 2 phosphate. Remember that the 2 tells us what the charge on the metal is. Because copper is a transition metal, it can have multiple possible oxidation states, and so when we write the name, we have to say what the charge is. So this is copper 2. I'll write Cu2+. Phosphate is a polyatomic ion. It has the formula PO4 with a 3- charge. So now to determine the formulas, if I just want to use the balancing, I know that the lowest common denominator between 2 and 3 is 6, so I'll need 3 coppers and 2 phosphates to be 6, or if I swap the charges for the subscripts, the phosphate will get a 2, and the copper will get a 3. So the formula is Cu3, and I need 2 phosphates, so I have to put the whole thing in parentheses, PO4, 2. And so the 2 is distributed to everything inside the parentheses, both the phosphorus and the oxygens. All right, let's go to the next example. All right, in these examples, we're given the formula and we want to know the name. When we're naming these, we follow the same rules as the binary ionic compounds. It's just if I have a polyatomic ion, all I have to do is give its name. In the first case, it's composed of 2 polyatomic ions. The first one, NH4+, is the ammonium polyatomic ion, and carbonate is CO3 2-. And so all I have to do is just give the names of the polyatomic ions. So it's ammonium carbonate. All right, in the next example, we want to give the name for this compound. So this is just composed of a single polyatomic ion. We need to know that NO3- is the nitrate polyatomic ion. Now, this is paired with a metal that is a transition metal, so I don't know the charge ahead of time that iron is going to have, but I can figure it out based on the anion, in this case the nitrate, that it's paired with. So I have that nitrate is -1. There are 3 nitrates, so in order for the whole compound to be neutral, the iron must have a +3 charge. Or, as I did with the binary ionic compounds, I can write a simple formula for determining the charge on the iron. Right? So my algebraic formula is, I'm looking for iron, that's my unknown. It and the anions have to add it to be 0. So I've got +3 nitrates. Each one of those is -1, and that has to add up to be 0. So if I solve for the iron, I get that iron is +3. So I know that it's iron 3. So when I write the name, I would write iron, then give the charge on that iron, 1, 2, 3. Nitrate.